Hi guys, it's Terry here again, right? I'm going to be continuing with the solutions for the June 2021 paper. As usual, providing quality tuition for you guys, right? My new Form 4 class will be starting in the first week in August, and I continue with my Form 5s in August as well. And this includes not just CSEC Maths, but chemistry, physics, and Add Maths as well, right? So let's continue with this paper here. Question I'm going to be doing now is the third question. So the third question here was a pretty straightforward one. So they gave us a right angle triangle. How do we know that? Look, this is 90 degrees here, right? So they said triangle PQR, in which angle QPR is 62. So they gave us the angle, they gave us PQR is 90, and they gave us a length, which is 11 cm. So the first part, they want the size of the angle PRQ. So PRQ is this angle here. That's my angle of interest, right? Now, let's call that angle theta here. Now, whenever we have a question like this, we need to understand exactly what we are doing, right? So we want the size of angle theta, which is PRQ, right? Now, this part here is pretty straightforward. You know that the sum of the interior angles of a triangle is 180 degrees, right? Remember, this here is 90 degrees. So if you want to get PRQ, right, all we need to do is to take 180 degrees minus, right, 62. So we add in the other two angles. So 62 plus 90 degrees. And this here is going to give me 180 minus. So 62 plus 90 should give me 152. So 62 plus 90, yeah, 152. Right? And then we're going to just subtract. So it's 180 minus 152, and you're going to get 28 degrees, right? So this is 28 degrees. That's it, right? As simple as that. Second part now, they want to get the length of the side RQ. So you want, where is RQ? So you want this, so we know this is 28 degrees. So let me just put this here. This is 28 degrees here. And the question wants us to work out this length here, which is RQ, right? Now, we have different options here, right? We can decide to use the 62, the 28. Doesn't really matter what you use, right? But you're going to get the same answer either way. So let's, one second, let me get, so let's bring this diagram across here. Right? So we decide what we're going to use. So if I use the 62, I'm going to use the 62, right? If I use the 62 as my angle, then this side here is going to be called my opposite, right? The side opposite my angle, my right angle, is always called my hypotenuse, right? That's what this is. And therefore, what I'm left with on the side here is called my adjacent. Now, before you decide what you're going to use, whether it's sine, cosine, or tan, you need to remember this. So, ka, to, a, right? These are my trigonometric ratios that we need to know. Now, I'm going to use, I have my hypotenuse, which is 11, right? You want to figure out what is the opposite side. So we want to figure out opposite, and we have our angle. So we have opposite, we have hypotenuse. Therefore, the only ratio that gives me opposite and hypotenuse here will be sine. That's why I'm using sine. So we start off by writing sine. Write down what the ratio is first. Sine theta is opposite over hypotenuse. That's what the sine ratio is. So sine, the angle that I'm using in this particular case here is my 62 degrees. 62 degrees, which is equal to my opposite, which is RQ. That's what we don't know. This is RQ divided by my hypotenuse, which is 11, right? Now, how I usually teach my classes, I tell them to write the sine 62 in this case here as sine 62 over 1. And then all we're going to do now, we are going to cross multiply. So we're going to say RQ by 1, which is going to give me RQ is equal to, and you cross multiplying the sine 62 by 11. So that's, I will typically write 11 first, multiply by sine 62 degrees. And then we're going to use our calculator in order to do that piece. So let's pull up the calculator here, right? And let's do that. So it's going to be 11. So 11 multiplied by sine 62, right? And I'm going to get 9.71, right? So I'm going to get 9.71. So that's what I'm going to use. So my answer here is going to be 9.71 centimeters, right? So there are alternative ways you could have worked this question. You could have used it 28 degrees if you wanted, right? But I use it 62, right? So that's my length of R cube. So this first part was pretty okay. It should have been pretty okay. Now let's look at this question here now. So this is a transformation question. So the diagram below shows three triangles, Z, X, Y, and Z on the grid, right? So we have some triangles here, right? They all look identical to me, right? So they are all congruent triangles here, right? Now, let's see what we have here. So they said triangle X is mapped onto triangle Y by a reflection. State the equation of the mirror line. So if you look carefully, you realize this is where X is. This is triangle X, and this is triangle Y. So it's a reflection, right? So therefore, if I were to join these 2 points, right, and also these 2 points, right, my mirror line, right, is really the perpendicular bisector of these lines. So therefore, my mirror line is actually my x-axis, right? My mirror line is my x-axis, and the equation for my x-axis is the line y is equal to 0, right? So here, this is my mirror line. If I fold the graph paper along that line, those two triangles are going to line up exactly, right? That's how we look at reflections. So when they ask you here, what is the equation of the mirror line? You're going to tell them y is equal to 0, right? Don't just say the x-axis, it's y is equal to 0. So let's clear this here now. So that's that first part, right? So they're asking us about reflection. What else do they want to know now? So the next part there, in part 2, they said describe fully the transformation which maps triangle X to Z. So the triangles we're looking at now, we're looking at this here and we're looking at this here, right? Some students can look at this very easily and they can figure out what that is. So I'm going to give you, so hold on, right? Let's give you something here, and this is going to help you understand this perfectly, right? So I have triangle X, that's a red triangle, and I have triangle Z, which is the after the transformation. So we're trying to figure out how is X moving to Z, right? Now that can be a translation because the orientation has changed. Now usually when the orientation has changed, it could be a rotation. Now let's see if that is really a rotation, right? So hold on. So I'm going to try to rotate this triangle X here, right, about my origin, right? My origin, whenever you're rotating something, you need a center of rotation. So I'm going to use my origin as my center of rotation, right, which is the point 0, 0. So look at what's happening to this triangle as I move it. So I'm going to move the triangle slowly, slowly. I'm rotating about the origin. So watch carefully what's happening to that triangle X. It's still moving. It's still moving. Let's see if it lines up exactly with triangle Z. So as you move, keep moving, keep moving, keep moving, keep moving, keep moving, bam. You realize triangle X lines up exactly with Z. And notice what happened there. We rotated our triangle 90 degrees in an anti-clockwise direction, right? So let's look at it again. Watch what's happening here. I started off with my triangle X and I started to rotate 90 degrees. So I'm rotating in an anti-clockwise direction. Keep rotating, keep rotating, keep going, right? And then boom, reach 90 degrees and it lines up exactly, right? So it has lined up exactly. Now, the question asks us, so let's just move this here a sec, right? So the question says, let's go to the question it says. So it says, describe the transformation fully. Now, we already identified that the transformation has to be a rotation, right? So they say to describe it fully. Now, they're given 2 marks here. Typically, they would give some like 3 marks for this. So so it's a rotation, right? It's a rotation, right? We need to say a rotation about what point? So rotation, so we need several things we need here. It's a rotation, right? 90 degrees, right? In an anti-clockwise direction. You saw on the diagram what happened. In an anti-clockwise direction, right? About the origin, right? Which is my point 0, 0, right? This is all that is required in order to get this mark here. It's a rotation, yes. It's a rotation of 90 degrees anti-clockwise about the origin. Now you could have said, in an alternative, you could have said 270 degrees in a clockwise direction. You could have said this as well. Right? This is an alternative answer. So you could have said this as well and still get a mark. Right? So that's that. Now, the next part now, they said on the diagram on page 10, translate triangle Y using the vector -7, 1. Right? So we want to transform triangle Y. So triangle Y is, so let's erase some of this clutter here. So we want to transform triangle Y, right? So this is triangle Y here. And the vector we're going to use here is -7, 1. So this is my vector. My vector is -7, 1, right? Now these numbers tell me something. So this here is, I'm moving in my X direction and I'm moving in the negative direction, or I'm moving left, right? That negative signs mean that I'm going to move left. This one here is my Y movement, and this means because it's positive, I'm going to move up, right? So here's what you're going to do. Every single point on triangle Y, you're going to translate those points. So this point here, I'm starting with this. I'm moving -7 in the X direction. So you're going to go 1, 2, 3, 4, 5, 6, 7, right? And then I'm going to move 1 up. If you move 1 up, then this is where this point is going to become now, right? So I've done that with the first point. Then I'm going to do it, let's say, with this point here. So I'm going to go 7, 1, 2, 3, 4, 5, 6, 7, and then I'm going to move 1 up. So I'm going to come here, right? That's my coordinate for the next point. Then I'm going to use this point now, and I'm going to go 7 to the left and then 1 up. So 1, 2, 3, 4, 5, 6, 7, and then we're going to go 1 up. So look at where my triangle is. So my new triangle is going to be this. Right? That's my new triangle here. That's what they want us to do here. Right? So let me give you another diagram here, and I'll show you exactly what I mean. Right? So I have triangle Y. Right? And I'm going to perform a translation with this. Right? So let me select that again. So this triangle here, and we're going to perform this. Right? So that's where my new triangle is going to be. Right? After a translation. Right? So that's where it is. So let's take this off here now, right? So that's how we do a translation. Now, what else do we have to do here? I think we have a next part. Yeah. So that's this part. The last part now, on the diagram, right? They want us to take our center as 0, 0 and a scale factor of 1/2, right? So basically, we're going to perform an enlargement. But in this case here, because the scale factor is less than 1, it's really a dilation. It's going to get smaller, right? If your scale factor was 2, then it's going to be twice as large. If the scale factor is 1/2, it's going to be decreased. So what you need to do, right? So let's go back to this diagram here. And let me show you something first. So let's erase this for now, right? Don't need all that clutter. So the triangle we're dealing with, let's make sure we're choosing the correct triangle. It's a triangle X, right? So the triangle we're dealing with here is this guy. We're looking at this triangle here. This is our center of enlargement, right? Now, if you want to do an enlargement or a dilation, what we do, we draw a line from our points, right, or vertices of this triangle here. So you're going to draw a line, go in here, draw a line, go in here, right? And what's going to happen here is, because you want to perform a dilation, scale factor per half, it means that the distance from my center of enlargement to each of the vertices, so this here is going to be a coordinate of one of the points of the new triangle. This is going to be an x1, right? That's midway. And the next one probably maybe here, right? Depending on how you draw your diagram. So then the new triangle is going to be looking like this. So that's my new triangle here after it undergoes that particular transformation. It's a dilation, right? The scale factor is a half. That's why it's a dilation. The triangle is going to get smaller. But I want to show you it on my diagram here as well, right? So take a look carefully. We have triangle X here. So let's go back here, right? Let's put back this here. And watch what's going to happen here, right? I am going to perform, right? So look at this. The question says we're going to transform triangle X. But what's something? If I increase my scale factor, let's say your scale factor is more than 1. Watch what's happening. Your triangle is going to get larger. That's what's happening. But in this particular case here, my triangle, they said the scale factor is a half. So let's go back in time now. Let's reduce the scale factor. So look, I'm reducing the scale factor, reducing the scale factor, reducing it to a half. And look at where your new triangle is. You realize that the triangle has gotten smaller, right? So that's it. That small triangle is what they want for the answer. That's what the answer is, right? So that brings us to the end of my third question here, right? So let's move on to question 4, right? So let's do question 4 one time. So the diagram below shows two lines, right? L1 and L2. So they gave us the equation of L1, right? It's x plus 2y equal to 10, right? The line L2 passes through the point. So they told us where L2 is passing through. It's passing through this point here. And they said both lines are perpendicular. What that means is that because the two lines are perpendicular, they cut each other, but they cut each other at 90 degrees, right? Now let's see what they want for the first part. In part 1, express the equation of the line L1 in the form y is equal to mx plus c. So let's go back. What is the equation? X plus 2y equal 10. So my equation is this. X plus 2y is equal to 10. And they want us to write it in the form y equal mx plus c. So I can write it as 2y is equal to minus x plus 10, right? Now I have 2y on the left hand side here. So what I need to do is to divide everything by 2. So this becomes y is equal to minus a half x plus 5. So that's my equation here, L1, in the form y equal mx plus c. Next thing they want, state the gradient of L1. Now remember, if you write an equation in this format here, it means that this here m is my gradient, right? So this here is my gradient. So therefore, the gradient in this particular case here is going to be minus a half, right? So the gradient of L1 is minus a half. Now the second part here, determine the equation of L2. Now since we know L2 is perpendicular, right? To figure out the gradient of L2, so the first thing we need the gradient of L2. Now, you know the gradient of L1 is this. Gradient of L1 is equal to minus a half. Now, when you're talking about perpendicular signs, the product of their gradients will be minus 1. So if I know the gradient of L1, the gradient of L2, all I need to do is to put a minus sign in front of this number here, so it becomes positive, and I need to invert it. So the gradient of L1 has to be equal to 2, right? So look at something here. This is L1, which is minus a half, right? L2, the gradient is 2. If I multiply these two numbers here, this will cancel with this, and I will end up with minus 1. For perpendicular lines, the product of their gradients is minus 1. Now, we know that L2 passes through the point 0, minus 5. So L2, right, passes through the point 0, minus 5, right? Now, that particular coordinate they gave us here is actually my y-intercept, right? So for those of you who went and worked this out, you didn't have to, right? So therefore, the equation, right, is actually y is equal to 2x, because that's 2 is the gradient, and your y-intercept is minus 5. So it's just 2x minus 5. There's no calculation to be done here. So this is an easy 2 marks in the question, right? Now, part B now. They said determine the value of f of 9, right? So they gave us two functions, right? And they want f of 9. So f of x is equal to 1/3 x plus 4, right? And you want to figure out f of 9. All you're going to do is substitute 9 into this equation anyway you see x. So this is 1/3 multiplied by 9 plus 4, right? So this 3 will go into this 3 times. So therefore, this is 3 plus 4, which is equal to 7. Easy 1 mark. Next part. Calculate the value of fg of minus 3. Now, let's see what my functions are. So f of x is 1/3. Let me just copy this instead of writing this over. Alright, so this is what we have here. So you want to find, so this is a composite function here, right? So this is a composite function. So what I would do, I would work out g of minus 3 first. So I'm working out g of minus 3. So I'm going to plug this into this function here. So this is 3 multiplied by minus 3 divided by minus 3 plus 1. Now you need to be careful with these things. So 3 by minus 3 is going to give me minus 3. And then minus 3 plus 1 is going to give me minus 2. And therefore this is going to give me 9/2. But I'm not done with the question as yet, you know. That answer that I got for g of minus 3, I need to plug that now into the function f. So I'm going to find f of 9/2, right? So this is going to be 1/3 multiplied by 9/2 plus 4, right? So this 3 would go into this 3 times. So this is 3/2 plus 4, right? So that's going to give me 5.5 as my answer. So you can give your answer as a mixed number, or you can give it as an improper fraction. So some of you all may have given it as 11/2, and that's fine, right? These are potential answers, right? So that's how we work that out. The next part here now, determine the value of x for which g of x is equal to 5/2. Again, let me write down what the functions were, right? So these are my functions, and we are saying that g of x is equal to 5/2, but this is g of x. So therefore, what I'm going to do, I'm going to say that 3x over x plus 1 is equal to 5/2. 5/2, right? And all we need to do now here is to solve this equation. So we're going to cross multiply. We're going to say 3x by 2 is equal to 5 multiplied by x plus 1. So therefore, 3x, right, multiplied by 2 is equal to 5 multiplied by x plus 1, right? So 3x by 2 is going to give me 6x is equal to, you're removing these brackets here using the distributive law. So it's 5 by x and then 5 by 1. So this is going to be 5x plus 5. So therefore this is going to be 6. This is going to be 6x minus 5x is equal to 5. 6x minus 5x is going to give me x. So therefore x is equal to 5, right? So that's my answer there, guys, right? So